Oh, welcome to another episode of the Growth Compass. Shout out to our sponsor, Senders. If you want to do email deliverability correctly, you know where to find the link. But without them, it would not be possible to interview cool people doing cool things like Michael. Nice to meet you. Welcome.
Thanks so much, Blake. It's good to be here.
Yeah, so just like what we were saying, this is slightly unconventional in a way that I think is going to really expand the capabilities of this podcast, which is a lot of my discussions over the last couple months have been around people building businesses in the AI space. There's all of this conversation about what it is and how to use it, and everybody has their own opinions, and so that's why I think it's really important. I'm really excited for all the things that you have to bring to the conversation, Michael. So for anyone that doesn't know yet, if you could give a brief introduction of yourself and what you're building.
Yeah, sure. No, thanks for inviting me. So I've been an AI researcher, well, arguably since I was a teenager, but so I grew up in the suburbs of Philadelphia and went to college and studied computer science. But I was very, very interested in the notion of AI. What is it that we can actually depend on the computers to be able to do to help us get the computers to do things for us? And so that's been my research area. I study reinforcement learning, which is a subfield of machine learning or AI, focused on getting machines to learn from evaluative feedback, like how you doing. So they already have a very growth kind of perspective built into what we're doing with reinforcement learning agents. We're trying to get them to maximize reward and be better, do better. So they measure various metrics and they try to improve along those metrics. And I always thought that's like the more interesting problem to solve in the space of machine learning. Much of machine learning is focused on the question of basically imitating, like mimicking, which is not as interesting, right? It's really just like, okay, well, here's what I want you to do things like that, and they'll do things like that. But if we actually give the systems the ability to improve themselves according to some metric, that's much more exciting. They can surprise us in interesting and potentially dangerous ways. So that's always drawn me to that field. The last couple of years, I've actually worked as in the federal government. I was working at the National Science Foundation as the division director for information and intelligence systems, which is the AI division at the National Science Foundation, which basically funds probably close to 80% of AI research that's happening in universities and academic circles. So that was really fun. It was cool little thing to get to focus in on my sub area. But then like 5 months in, ChatGPT happened and everybody went bonkers because AI felt much less like an abstraction to people and much more like a tool that they could start to use immediately. And so that changed my job at the National Science Foundation because even though I was in the computing directorate, focusing in on my subfield, the biology directorate and the geology directorate and the engineering directorate and the social behavioral economics directorate, they all suddenly cared very deeply about AI. And so I ended up getting engaged in a lot of conversations and a lot of efforts about how they could fund AI research that was relevant to their field, how they could be using AI in ways that could help them be more effective researchers. Everything, everything about AI just sort of became super relevant across the agency. So I didn't get a promotion exactly, but I did suddenly get a broader portfolio, right, to actually pay attention to what was happening everywhere. 3 months ago, I actually got back to my home institution at Brown University and was asked to be the inaugural associate provost for artificial intelligence. So, like, if not enough people really like artificial intelligence is a weird word, I don't really know what it means. Provost is even a weirder word. People don't know what that means. And if you stick associate in front of that, then like all bets are off. Nobody has any idea what this is. But what my job is to coordinate AI efforts at the level of the entire university. So even though I'm a computer scientist, I study computer science in the computer science department, I teach classes in the computer science department, there's now relevant things happening in AI in every department of the university. So that's every academic department. Are there people teaching about AI? They're using AI in their research. But then also I have a meeting coming up this week with the dining services. Like we're going to talk about the use of AI in the dining services on campus. And so a university is kind of like its own little town, and everything that happens in a town is happening And AI is relevant to all of it. So it's a very exciting time. It's a very disorienting time, but there's a lot of opportunities.
So being in this field with the perspective that you have for how it's evolved, um, before the ChatGPT thing happened, before, after, however you want to take it, for you personally, what draws you to this field, this technology, computers in general? Like, just for a second, about you, what is it about this
Sure.
lifestyle that's attracted to you?
I certainly, when I was a teenager and got drawn, like I was at the Plymouth Meeting Mall in Pennsylvania, and I would hang out outside the Radio Shack because they were selling a computer. This was 1978, 1979,
Huh.
and they had a computer that you could like buy and bring to your house. And like I used to try to stump it. Like I knew that if I typed print and then one plus one, it would return two. But like, what if I do one plus one plus one? Like, I bet no one's asked it that before. And then it'd be like three. I'm like, oh my gosh, how does it know everything? It knows everything. And I was totally smitten with the idea that this box of electronics, like not that different from a television set, it really looked like, yet it could sort of do something that I would think of as thinking. Right? That I could write arbitrarily complicated arithmetic expressions, which I was just at the time learning how to do as a junior high school student. um, it had all that built into it already. Like how could it do that? How can it enable me to do things that I couldn't otherwise do? And so I was all in at that point. I still think it's the most interesting thing in the world. I once I taught myself how to use it and became sort of a programmer, I was like, oh my gosh, my brother and sister, they're going to be dying to know about this. And so I'd bring them into my room, like, come in, let me show you this thing. This is how a for loop works. And I would lay it all out for them. And oh my gosh, they could not care less, right?
Yeah.
And I was like, no, you're wrong. Like, you're wrong. This is super interesting. It's you that's a problem. But you know what? Maybe you're just too old. So someday I'll have children, and then I will teach them from day one how exciting this is. So then I had children, and I taught them from day one how exciting it was, and they still didn't find it interesting.
Wow.
It's like, how is this possible? Wait, did I not show you for look? Wait, arrays. I have to tell you about arrays. They're amazing.
Yeah.
So I don't know. For whatever reason, speaks to me very deeply. It lives at this boundary between an inanimate object and an animate object. Like it's sort of a life form, but it's clearly not. It's just stuff. So it bends my brain.
Amazing. Like an unbelievable origin story. I couldn't have asked for better than that. So then with all this energy that you've brought and interest, that's driven all the things that all the places that you've ultimately taken your research and your work and things like that. Again, to whatever wherever you want to take it, because it's a super large question. But before we get into like what it is and applications in modern times and things like that, from your perspective, how has it changed? How has this technology changed? How would you even answer that question? How has it changed over time? AI.
Yeah, that's so. Again, I have been in the field for a while, and from very early on, I was drawn to the more sort of statistical, mathematical piece of AI, which we refer to as machine learning. And most of what we're seeing today that's really having this huge impact on the world, a lot of that stuff is grounded in machine learning. So machine learning ended up being the kind of ascendant piece of AI and computer science. And one of the things that's super interesting is I remember having these like, late night rap sessions with my computery friends about like, if we could like what so there's this notion in computing called NP completeness. It basically says that there's a particular kind of problem where I like to pretend NP stands for nice puzzle problem. These are problems that you might not be able to figure out the answer, but if I show you the answer, you'd be like, right. Just like puzzles in a newspaper, like you might have a difficult time solving it, but then the next day the answer appears and you look at it and you're like, oh, well, sure. Yes, that's right. So it's hard to find the answer, but it's really easy to see that you have an answer when you have it. But this is a really core concept in computer science that basically says a whole suite of really interesting and important problems. They're all actually the same problem. They're all NP complete. They're all just, if you could solve one of them, you could solve all of them. They're just essentially the same problem. There's a question of, okay, what about intelligence? What about AI? Like, is AI, what problem is that? And so we used to talk about this notion of AI completeness. Like, what would a problem be that if you could solve that, then really anything having to do with intelligence, you'd be able to solve that as well. Like, they're really all fundamentally the same thing. And if you're having trouble with a problem, like finding the boundaries, like in an image, finding the edge of like where your head is and where your shoulders are versus the background, like this is the thing that computers do all the time now, right? They segment your foreground image from the background so they can give you a different background, blur out the stuff behind you. But that problem of finding the edge is really hard and arguably AI complete, which is to say, I can give you examples of images where the only way that you can figure out what the edges of the object are is if you were fully intelligent. Right. So we used to talk about what it meant to be AI complete. And one of the things that we said with AI complete was just guessing what the next word was. Like if I start a sentence and then I stop, like to know what a likely next word would be, you'd have to have like full intelligence. Like even though that's a really simple, direct question, it really is equivalent to the full problem of intelligence because I can take any question that I might have as an intelligence question and then boil it down to, well, it all just comes down to this next word. Or like an intelligent person would say A, the following, B, the following, C, the following. Which one would you say? And then just guessing that one last little piece is as hard as being smart. And so we used to say guessing the next word would be equivalent, but we didn't really believe it. Like, it's not like if we built a machine to predict the next word, it would actually be intelligent. Well, it turns out that was wrong because that's what we've got now. So these chatbots, they're fundamentally trained to just predict the next word. They've seen tons and tons of text, and they're just trained to be very, very good at guessing what's a reasonable thing to say next. And kind of remarkably, not only is that useful for generating fluid text, right, to making it sound like a person talking, but it can answer questions. It can write programs. It can compose poetry. Like it's crazy. We said in principle this would be possible, but the fact that we're actually seeing it now, and being able to use it now and build systems on top of it, that's so new. If you say what's changed, that's what's changed. We discovered that in fact problem of predicting the next word was hiding the entire problem of intelligence. And we know how to train that. We know how to build machine learning systems to do it. So guess what? We've kind of cracked a big chunk of what it means to be intelligent. I don't think we're all the way there yet, but I think that step forward that we've taken is so much bigger than anything that we've seen before in the field. It's just remarkable.
So two questions within this theme. So the first one is that they're to an average individual. I mean, anybody really, like including myself. You know, the tipping point that we saw was ChatGPT because, like you said, that's when it became a more tangible thing rather than this like thing that was just up here and like very theoretical. But again, from your perspective, being in this field for so long, what was the tipping point? Is that the tipping point, or was there something prior that happened that enabled that to then occur?
Yeah. So the name ChatGPT stands for. So the chat is chatting because it's set up to actually be conversational, and things before that weren't quite there yet. And the GPT is for generative pre-trained transformer. And so all those concepts existed before ChatGPT. That's what ChatGPT is. The breakthroughs were real, but not as visible, I think. So when transformers were invented, that's the T in GPT. Um, that was really a big deal, but it was hard to tell what kind of impact it would have, right? Because it was more in this sort of technical space. It was originally devised as a way of translating between languages. That's why they're called transformers. They take a segment of text and they transform it into this other segment of text. Um, People then took that model and they said, well, you don't need two languages, really. You can do, even with one language, you can squeeze an awful lot out of it. And so it became simplified in some sense. The pre-trained just means we're building on a huge data set, and we're gonna train up that model using those ideas. And generative is we're not just predicting the next word, but we're predicting a probability distribution over all the words. And so all these things were already out there, and we were starting to see. I was already playing with in my book Code to Joy, which I welcome people to buy. I tried really hard to make it accessible and maybe funny and informative. Um, I actually started writing that before ChatGPT, but I included a section on GPT. It was GPT-2, it was pre-ChatGPT, because it was really interesting in terms of its ability to know things about the world just by being trained on text. And so we could see the roots of it, but I think a lot of us thought, well, that's as far as it goes. Like we have to do things to it to really turn it into something, I don't know, more conversational. And it turned out that if you just scaled up the amount of data that you gave it, it could become remarkably uh, conversational, remarkably fluent in being able to process language. And so yeah, it was both new and not new, right? Like all the pieces were already
Right.
there, but the ChatGPT moment wasn't just everybody seeing. It wasn't just the uninitiated seeing the new potential. It was us experts too, like people who had
Right.
been marinated in the field hadn't really appreciated. Oh my gosh, if you just scale this up, it's not just changes in quantity, but changes in quality. It becomes like a different kind of entity, and we always thought there'd be a way to get there, but we didn't think it would be this kind of weird back door.
But was it just the ability to have the resources to scale it up? Had nobody scaled it up before OpenAI did?
So, right, scaling up, like just the engineering necessary to do that is a big deal. We wouldn't have ChatGPT at all if we didn't already have, I don't know, the internet, right? So the internet, which is really designed as a way of just moving data around, encouraged people, and I remember I remember the early days of the internet. It was the case that we would ask the question, why would anyone ever put up a web page, right? Because a web page is something that's useful to you, but it's effort for me. So why should I put in effort for something that's going to make your life easier? And so we were like, this is never going to work. Or at least that was one of the theories. We're like, we're going to have to find ways of encouraging people. Otherwise, it's just going to, like so many things before that, too much effort means nobody's going to do it. It won't
Right.
take off. But it really, and as you know, it really did take off. And so people just started putting their whole lives on the
Yeah.
internet. Like we have all our conversations through the internet, we post things, we share pictures. And so suddenly all of the data about us was now being absorbed by the internet, right? It was all getting out there. Without that data, without all the stuff that people posted, there would have been nothing to train ChatGPT on. So
Sure.
there was no getting this off the ground. There was no way that you could do what you do with ChatGPT by just asking people, could you just write some text for us? Or can we just take a couple books that people have written? No, you need that internet scale quantity of text before you can start to squeeze it and pull out that insight so that you can build a language processor out of it.
Got
And
it.
so yeah, so that was so the engineering scaling of the actual computation side, on the data side, and there were changes to the algorithms. There were things that we started playing with neural nets, which are the basis for a lot of this stuff. Well, in the 50s, but I wasn't around for that one. But in the 80s, and I was around for that one, and it was very limited into the sorts of things that we could train. They'd get like clogged up really quickly. And so it wasn't until years later, right before this kind of big explosion, that people figured out how to train these systems more reliably so that you could actually train much deeper
Right.
networks with way more units. We were kind of limited in the 50s, we were limited to one layer of weights. In the 90s or the 80s, we were limited to two layers of weights, which is a huge step of doubling.
Yeah.
Um, but then it became clear the 20 teens, and so that we had new algorithms that could actually scale up to 20 layers, 30 layers, 50 layers, 100 layers. And a lot of what these language processing algorithms or neural networks do is they each layer is chewing up a little bit more of the information and making more connections. And we wouldn't if we didn't have that depth, we wouldn't really be able to train them to do much of anything. So there was an algorithmic advantage that happened as well.
And it was just there were, and I'm just pulling this from the available chatbots and things like that. So there was like OpenAI working on this research, Google working on this research, and Anthropic working on this research, and it just happened to be that OpenAI was the first one to reach that critical threshold of launching a chatbot. Is that really just where it comes down to?
Well, so the transformer, which is the neural network that underlies all this stuff, was invented at Google.
Okay.
It was actually co-invented by one of my former students, Noam Shazir, who had been playing with these ideas since the 90s, one way or another. Like he kind of saw where this could go and just was sticking to it. And year after year, it was like, this is kind of a waste of his time. Like he's a super brilliant guy. I'm like, oh my gosh, he's wasting his time. It's so sad that the universe has this brilliant person in it and he's wasting his time. Well, it turns out it all paid off, and it's really changing the way that the world works because of the efforts that he and his colleagues did. So that came out of Google, and Google was playing around with it. And Noam, my former student, and among others that were part of that, really saw the potential, and they wanted to scale it up right away. And Google was like, let's just take a beat. Let's just
Got it.
we're not quite ready to release things that have conversations with people, because what if the conversations lead them to do bad things? And so Google, which I think arguably was the right attitude, right? Like, it really would be nice if we take it a little slower and make sure that it's safe before we just release it on the entire population. Um, but OpenAI was playing with it. Meta was doing this stuff as well. So they all had transformer efforts that were ongoing. And yeah, I think that OpenAI, I think their philosophy had attracted some really good people in the beginning, because it was supposed to be open. Or it wasn't supposed to be a for-profit company. It was supposed to be like, we think this is a really important technology. We want to develop it in the open because we don't want anyone to have a strategic advantage. But then when they got a strategic advantage, they're like, you know what? I think it would be good to maintain our strategic advantage.
Yeah,
So,
yeah, yeah. Okay, got
so
it.
yeah, it is
Understood.
what it is.
No, well, thank you so much for laying that out. I've always been curious about that. So I have two more, I think, like general directions that I'd like you, and one of them is your approach to implementing this at Brown. But my first question is, when you experience, I mean, I guess hard to actually define, but just your average individual, and they are talking or thinking about AI or thinking about utilizing it, what is a common way that people try to understand this technology that is not to their benefit, in the sense of like actually being able to utilize it to its capabilities?
That's a really interesting question. I think it's quite tricky, because I think the two failure modes that I see are to go in two different directions. One is to say, um, oh, it's just a machine. So I'll just think about it like every other program that I've ever worked with. Because people, I don't know if you play with Google, right? You start to learn there's better and worse ways of asking queries, of formulating queries that are more likely to get you good answers. I think most people do that. I know I do that, and I know that I can out Google many people. But so I think there's a skill to that, of formulating your questions that are like Google friendly. So you could be like, well, it's just like that. So we just have to learn how to do it like that. I think that's incorrect, because it's so much more sophisticated. It's trained on a trillion words of off the internet, and nobody has a mental model that can encompass a trillion words. Like, it's just a weirder thing than that. But then the flip side is to think of it as being too much like a person, and to say, oh, it's basically a human being. Everything that it says, it has a reason, it has intent, and none of that is really true, right? It's just they're trained to be engaging. They're trained to be informative if they can be so, but they don't really get it. They're not people. And so I think you can make big mistakes by going too far in either of those directions, treating it too much like a person and not treating it enough like a person. The what seems to be successful are the people who treat it kind of like a very particular kind of person. And I don't know how to put that into words, but it is the case that the people who are very effective have learned to treat it in a way that it needs a lot of stuff kind of laid out and explained in words in an evocative way. And if you can kind of get it into the right mindset, it can actually produce really value. If I'm talking about generative AI here, chatbot type AI,
Okay.
but if you can get it into the right kind of context, it can be really, really helpful. But it's really up to you to get it into that context. And so I think it takes a lot of practice before you get really good at it.
Well, is it the case that you can ask Claude, for example, to write a prompt for Claude and it'll be high quality, or is that kind of a cop out?
So you absolutely can do that, and there is some advantage to that. But I don't think anybody should believe that it's going to somehow extract from your brain what you really intended, right? So you have to describe it to the computer, and then you can say, help me phrase this better. But of course, if it didn't understand you in the first place, it's not going to be able to do that. And so you have to kind of hit it with everything that you've got. You have to be able to explain it, sometimes in multiple ways. If you've ever tried to write, exam instructions for somebody, or just any kind of, or I'm going out of town for a little while, someone's going to come and take care of my house. Like, try to write down all the instructions so that they're complete. Oh my gosh, it is so hard. And it's that hardness. It's that idea of, like, you're trying to express in words the thing that you want this huge neural net to do on your behalf. You have to be patient, right? You have to actually kind of lay it all out, and don't expect that it's going to read your mind and jump to the right answer.
Gotcha. So I do want to just double check on time. I know we set it up for. I do have obviously a lot of questions for you, but do you have a hard stop at?
I have a stop, so it would be good if we could sort of, I don't know, land the plane if we could.
Great. Okay. Cool. So then we'll return. We gotta have to do a second one then.
There you go. There you go.
But so this was an awesome intro discussion about AI. I'm definitely interested in continuing this. my last question that I always love a task is to land the plane is what inspires you.
Yeah. I'm very inspired by the idea of empowering people, of trying to convey information to them so that they can go off and do the things that they want to do, accomplish what they can accomplish, what they want to accomplish. And I think computing is a wonderful way to do that because a computer is kind of like a helper, right? It can actually do things on your behalf. And so to the extent that you can get the right questions in the right way and it can do work for you, I think that's empowering. And so I'm very inspired by giving people the ability to sort of unleash their creativity and accomplish their goals.
Yeah, well, awesome. Well, you definitely took a step to do that today. Thank you so much for your time. I'm seriously excited for the second time. Code to Joy, I believe, was the book that you dropped. Good. Definitely check it out. If there's is there if anyone else was inspired to follow along to your journey, what's the best way to do that? Hey, that's right.
So right, you can. I used to say Twitter. I'm using Twitter a lot less now. So there isn't. I do have a mailing list,
Great.
which it's mostly focused in on issues around science funding, but nonetheless, sort of AI and what we're doing and what other people could be doing is a part of that. And so I will give you. I don't have it off the top of my head, but I will give you the website to sign
Good. Do it. Sign up. Thank you,
up.
Michael. Looking forward to the next time.
Thanks, Mike.
Bye.